Welcome back, children. This is your Vanashri ma'am. Today I will be taking up the last part of acid-base salt, that is salts. In my earlier classes, I have already taught you about acids, their properties, how acids are prepared, bases, their properties, and how bases are prepared. Now in this class, I will be teaching you about salts and how they are prepared. So, first of all, what is a salt? A salt is a compound when an acid and a base react. And this compound salt is formed along with water. That is, when acid and a base react, salt and water are formed. Now, for example, HCl, hydrochloric acid, plus sodium hydroxide, NaOH, gives what? NaCl plus H2O. Similarly, say sulfuric acid, H2SO4 plus say potassium hydroxide gives what? K2SO4 plus H2O. Now, see, this is an acid. This is a base. Acid and base, when they react, they form salt and water. Okay. So, how is this salt formed? This salt is formed when the hydrogen atom of the acid is replaced by the metallic ion of the base. That is how sodium chloride is formed. And this hydrogen atom and the hydroxide ion of the base react, forming water. Similarly here, see, the two hydrogen atoms of sulfuric acid are replaced by two potassium ions of potassium hydroxide. Okay, so K2SO4 is a salt formed. Okay, so now that is how we define salt. So let us define salt. Salt is a compound. Salt is a compound formed by the replacement of hydrogen atoms of the acid by a metallic ion of the base. Okay, so that is the definition of salt. So salt is a compound formed by the replacement of hydrogen atoms of the acid by a metallic ion of the base. Now, sometimes it so happens that, for example, sulfuric acid has two hydrogen atoms. So, sulfuric acid, when it reacts with sodium hydroxide, instead of getting both the hydrogen atoms replaced, sometimes only one hydrogen atom of the sulfuric acid is replaced by one sodium of the sodium hydroxide. So, what is formed? NaHSO4, sodium bisulfate, plus water. So, what is happening? By partial replacement, out of the two, only one is replaced and one is retained. So, such salts are called acid salts. Why? Because these acid salts, when they are dissolved in water, produce H plus ions, which in turn produce hydronium ion with the water formed. That is why these acid salts exhibit all acidic properties when dissolved in water. Okay, so acid salts are formed by the partial replacement. By the partial means incomplete. Partial replacement of hydrogen atoms of the acid by the metallic ions of the base. Okay, so they are called acid salts. Now there is another type called basic salt. Now you can very well guess what is basic salt. Basic salts are formed by the partial replacement of hydroxyl group of the base by an acid radical. That means what? Basic radicals are those in which these basic salts are formed by the incomplete replacement of hydroxyl ions of the base. So that means example, basic lead chloride. It is PbOHCl. So basic lead chloride. Similarly, basic magnesium chloride. Basic magnesium chloride is MgOHCl. So let me show you how is this basic lead chloride is formed. Let me take the example of an equation. Say lead hydroxide, that is PbOH twice, okay, plus hydrochloric acid gives PbOHCl, that is basic lead chloride plus water. So these are called basic salts. Okay. Then double salt. Double salt. Now, double salts are formed by the union of two simple salts that dissolve in water and crystallize. Okay. So, double salts, how they are formed? When two salts dissolve in water, and after they dissolve in water, you crystallize it. So, a double salt is formed. Okay. So, double salts are formed by the union of two simple salts that dissolve in water and crystallize. Okay, so examples of double salts: potash alum. The formula is K2SO4 dot Al2SO4 thrice plus 24 water molecule. That means these two salts, when they crystallize, they also crystallize along with 24 molecules of the water molecules. 24 water molecules. So this is the double salt of potassium sulfate and aluminum sulfate. This formula is very important. These are asked not as a salt, not as a basic salt, nothing, but simply they will ask in section A, that is in the compulsory section 1, that is give the chemical formula of the following compounds. In that question you will get potash alum. So the chemical formula of potash alum is K2SO4 dot Al2SO4 thrice dot 24H2O. These you have to read by heart, because you must remember the number of water molecules correctly. Then the other example is Mohr's salt. This is very often asked in the boards. Mohr's salt. What is the formula? FeSO4 dot NH4 twice SO4 dot 6H2O. So that means Mohr's salt is formed by the union of ferrous sulfate, ammonium sulfate when dissolved in water. These two salts together with 6 molecules of hydrogen atom, together with 6 molecules of water atom, they crystallize forming Mohr's salt. Okay. Now other example of these double salts is dolomite. Dolomite, the formula is CaCO3 dot MgCO3. This does not have any water molecules attached to it. Okay. Then we will learn about mixed salts. Now, mixed salts. Now, let me tell you one thing. This time, since last year rather, this double salt and mixed salt are omitted from your scope. Okay. But still, I am just telling you because previous to that, these formulae were asked very often. That is why I am discussing. But otherwise, these are now omitted from your present scope of the syllabus. Okay. Now, just I will discuss with this mixed salt also, because in a mixed salt you have a very useful thing that we use very often commonly in our houses, that is bleaching powder. And this is usually often asked, what is the chemical formula of bleaching powder? So mixed salts are those salts that contain more than one basic or acid radical. So the examples of mixed salt, they usually a mixed salt is also another example of double salts and these salts only, but only thing is it does not again have any water molecule attached to it. So this bleaching powder is a very often repeated question in the boards. That is why I am mentioning this to you. And this bleaching powder formula, you must be aware of it, because while learning other topics like manufacture of chlorine, then in some of the organic compounds you will be again getting this use of bleaching powder. The formula for bleaching powder is CaOCl2. So this is an example of mixed salt. But this will not be asked to you under mixed salt. But as I told you, these are usually asked in the compulsory section and write the chemical formula of the following compounds. Okay. So now we will learn about preparation of simple salts. Okay. Methods of preparation. Methods of preparation of salts. Okay, again let me tell you, I have told you while teaching acids and while teaching bases, these chemical reactions are very important, and these usually do not ask directly as write the methods of preparation of salt, but each chemical reaction is very important in the particular type of question which comes. Complete the following chemical reactions. 5-mark question comes. In that, these equations are chemical equations are very important. Sometimes they give it what happens when two are combined, you have to write the products. Or sometimes they give the reactants in the form of an equation and they say complete the chemical equations. Okay. So now the first method of preparation of salt is direct combination. That is by heating two elements, one metal and one non-metal to get a salt. So direct combination. Now in this, sodium plus chlorine gives sodium chloride. Okay, so when sodium metal and chlorine non-metal, they react, they form a salt, sodium chloride. Or iron 2Fe plus 3Cl2. When iron reacts with chlorine, you get ferric chloride, that is FeCl3. Okay, then the second method is displacement. Now when a metal reacts with acid, a salt is formed and hydrogen gas is released. So this is, you have learnt in 9th standard types of chemical reaction. In that you have learnt displacement reactions. There the metal replaces the hydrogen of the acid, forming a salt. So zinc plus sulfuric acid gives zinc sulfate plus hydrogen gas. Okay, so this is preparation of a salt by displacement method. Similarly, iron plus hydrochloric acid gives ferrous chloride, that is FeCl2 plus hydrogen gas. So these are examples of displacement reactions and formation of salts by displacement method. Then you have decomposition. Okay, now decomposition of a, say, bicarbonate by acid. So for example, NaHCO3, this is a sodium bicarbonate. When sodium bicarbonate reacts with hydrochloric acid, the sodium bicarbonate decomposes, forming sodium chloride NaCl plus H2O plus CO2. Do you remember this equation? This equation you learnt in properties of acids. When acids react with carbonates and bicarbonates, you have learned carbon dioxide gas is released. Here you are learning preparation of salt by decomposition. Here, when bicarbonates react with acids, they form salt, water and carbon dioxide. Okay. Then neutralization reaction. This also you have learned in the preparation of, in the properties of acids. That is, when an acid, say nitric acid, and a base, this is called neutralization. When acid and a base react, form salt and water, this type of reaction is called neutralization. So when an acid, say nitric acid, reacts with, say, base sodium hydroxide, you get sodium nitrate, that is NaNO3 plus H2O. So this is an example of neutralization reaction. Similarly, HCl, hydrochloric acid, plus, say, sodium hydroxide NaOH gives sodium chloride, that is NaCl plus H2O. Okay, clear? Then the next method of preparation of acid is neutralizing an acid with an insoluble base. Insoluble base means which are not alkalis, that is metallic oxides. Okay, so hydrochloric acid plus magnesium oxide gives magnesium chloride plus water. Similarly, nitric acid plus lead monoxide, that is PbO, gives lead nitrate, that is PbNO3 twice plus water. Okay, then the last method of preparation is by action of alkalis on certain metals like aluminium and zinc. Okay, so when aluminium reacts with sodium hydroxide solution. Solution means aqueous sodium hydroxide solution. That means water is also present. So then you get sodium aluminate. That is 2 is of course a balancing wala 2 NaAlO2. Okay, this is called sodium aluminate. This also is very important for writing the chemical formula. Okay, plus hydrogen. Also, when zinc reacts with sodium hydroxide, you get sodium zincate, Na2, ZnO2 plus H2. This is sodium zincate. Okay. Similarly, another method of preparation is when acidic oxide and a basic oxide. Do you remember you learnt in 9th standard? Acidic oxide is an oxide of a non-metal like sulfur dioxide, carbon dioxide, sulfur trioxide, phosphorus pentoxide. These are examples of acidic oxides. And what is a basic oxide? A basic oxide is an oxide of a metal. So when these two combine, then also you get salt. So sulfur dioxide plus calcium oxide gives, when they are heated together, gives calcium sulfite. This is calcium sulfide. SO2 is what? Acidic oxide. And CaO, calcium oxide, is basic oxide. Okay. Similarly, when carbon dioxide reacts with calcium oxide, forms calcium by calcium carbonate, CaCO3. Okay. Then another method of preparation is double decomposition. That is, when a soluble salt and an acid salt react, they form an insoluble salt plus acid or salt. Okay. So, with an example you'll understand better. Suppose barium chloride, BaCl2, which is a soluble salt. When this reacts with an acid, say sulfuric acid, okay, what do you get? You get barium sulfate and hydrochloric acid. Okay. Similarly, silver nitrate plus hydrochloric acid gives silver chloride plus nitric acid. So, this is another method of preparation of salts. Then another method is silver chloride can be prepared by the reaction of silver nitrate and hydrochloric acid. So just now we have discussed. Okay. Then laboratory preparation of some salts. This laboratory preparation of salts is also not there in your scope. So you need not learn the laboratory setup, the procedure, nothing. But the chemical reactions are again important. So if you know the chemical reaction, that is okay. That is, you have already learned this. Iron plus chlorine, when they are heated, ferric chloride is formed. Similarly, when say zinc sulfide, that is ZNS, zinc sulfide, and dilute sulfuric acid or aqueous sulfuric acid, that is H2SO4. When they react, you get ZnSO4 plus H2. Okay, so these are all laboratory preparations of salts. These reactions we have already dealt with. I am repeating, but the experimental setup is not there in your scope. Okay, nobody will ask you, or they will not even give you the diagrams which are given in your textbook to identify. Okay, the chemical equations are important, which you have already done in the various chemical equations for preparation of salts. Okay, now properties of salts. Now, salts are usually electrovalent compounds. Electrovalent compounds means basically mostly they are ionic compounds. They conduct electricity in their molten state or in aqueous solution state. They conduct electricity only when they are either dissolved in water or when they are melted. Molten state means when the salt is heated and melted. Okay. In dry salt form, they do not conduct electricity. Why? Because in dry state, the ions are attracting each other, they are strongly bonded with each other. When you dissolve in water, the ionic bond or the electrovalent bond breaks up and the ions dissociate, and because of the presence of the ions, they conduct electricity. Okay, so these are the physical properties of salts. Okay, now the solubility of salts in water you have to remember, because sometimes in 1 or 2 mark questions they do ask. So you have to remember which salts are soluble in water and which are not. So all compounds of ammonium, sodium and potassium are soluble in water. That means all salts of ammonium, sodium and potassium are soluble in water. Similarly, all nitrates and nitrites are soluble in water. All chlorides, bromides, iodides are soluble in water. All sulfates are soluble in water. All carbonates, sulfides and phosphates are insoluble in water. Okay. So now, first what I told, which are soluble? All compounds of ammonium, that means ammonium chloride, ammonium nitrate, ammonium sulfate, all are soluble. Then all compounds of sodium, that is sodium chloride, sodium sulfate, sodium nitrate, they are all soluble. Similarly, all salts of potassium. Okay, so potassium chloride, potassium sulfate, all are soluble in water. Similarly, all nitrates and nitrites are soluble. Nitrates means sodium nitrate, aluminum nitrate, potassium nitrate. All nitrates are also soluble. Now, all chlorides, bromides, iodides are soluble, but there is an exception. Mercury chloride, silver chloride, lead chloride are soluble in hot water but insoluble in cold water. Basically, all chlorides, bromides, iodides, chloride, bromide, iodide, these are together called halides. Okay. So all these chlorides are soluble in water, except are soluble, but there is an exception. Okay. What is the exception? Mercury chloride, that is Hg2Cl2, AgCl, that is silver chloride, then lead chloride, that is PbCl2, okay, and these are three. What are they? Mercury chloride, silver chloride and lead chloride. They are soluble in hot water but insoluble in cold water. These are insoluble in cold water, but when you add hot water, they become soluble. So, soluble in hot water. Okay. Then I told all sulfates are soluble, but there is an exception. What is the exception? All sulfates, that is sodium sulfate, magnesium sulfate, then say ammonium sulfate, all are soluble except calcium sulfate, that is CaSO4, lead sulfate, that is PbSO4, and barium sulfate, that is BaSO4. These three are insoluble. Okay. Then I told all carbonates, sulfides, phosphates are insoluble. All carbonates, sulfides, carbonates means say magnesium carbonate MgCO3, say sodium carbonate Na2CO3. So all carbonates, sulfides means magnesium sulfide, then you have calcium sulfide. All these are sulfides is Na2, so NO2 should be subscript, Na2SO3, that is sodium sulfite. Okay, these are all insoluble in water. Clear? So anyway, this solubility is not a very often asked question, but sometimes as a 1 mark question they do ask, like choose the correct one, or sometimes they say is it a true statement or false statement? If it is false, correct the right statement. In that they may give you this, but of late they are not asking this, but earlier they used to ask. Then next one is a important definition that we will be learning, that is hydrolysis. Hydrolysis of salts. Now what does this mean? The phenomenon due to which a salt formed by a weak acid and a strong base, or by a strong acid and a weak base, reacts with water to give an acidic or alkaline solution is known as hydrolysis. Means what? The phenomenon or the process, phenomenon means process, the process in which a salt formed. How it should be formed? By a weak acid and a strong base, or vice versa. Vice versa means strong acid and weak base. When these type of salts react, this type of salt means a salt which is formed by the combination of weak acid and strong base, or strong acid weak base, then such a salt reacts with water to give an acidic solution or alkaline solution, then it is known, that reaction or the process or the phenomenon is known as hydrolysis. Okay, so define hydrolysis. Sometimes they do ask, if not in the boards, definitely in the school assessments they ask. So we define hydrolysis as the phenomenon due to which a salt formed by a weak acid and strong base, or vice versa, that means strong acid and weak base, reacts with water to give acidic or alkaline solution. Alkaline means basic. Alkaline solution is known as hydrolysis. Okay. Now, let me take an example. See, salts formed from strong base like sodium hydroxide and say weak acid like carbonic acid. What is that? Sodium carbonate, isn't it? Why? Because when a strong base like sodium hydroxide reacts with a weak acid like carbonic acid, what do you get? You get sodium carbonate, Na2CO3 plus H2. So this is an acid, this is a salt formed by a strong base with a reacting with a weak acid. So when such a salt is dissolved in water, so what is formed? Na2CO3. When it is dissolved in water, it is a reversible reaction. That is why we write reversible. Forms carbonic acid, that is H2CO3 plus and sodium hydroxide. So it will form, this is a strong base, so it will form an alkaline solution. Now, for example, salts of a strong acid and weak base is what example of is ferric chloride. Now, ferric chloride is formed by reaction of weak base with a strong acid. So, when such a salt reacts with water, say ferric chloride plus water, which is again a reversible reaction, forms a strong acid plus a weak base, that is ferric hydroxide. So, such reactions are called hydrolysis reactions. Okay. Now, some salts, as I told you, when they are dissolved in water and when we crystallize it, they absorb some certain number of molecules of water with it. So that is called water of crystallization. Those number of the water which is absorbed by the salt is called water of crystallization. So such salts, when they are heated, they lose that water of crystallization. Okay. For example, copper sulfate crystals. They absorb 5 molecules of water, and this is written as CuSO4.5H2O, which is blue in color. They are blue crystals. When you heat, what happens? They lose that blue color and it becomes white powder. Why? Because copper sulfate is white in color and it is not crystalline. Plus those 5 molecules of water evaporate when you heat it. Okay. Now these crystals, these have very much common use, and they have a common name, chemical name and formula. Very important. So you have to literally by heart and remember them. Now washing soda, though nowadays we don't use this for washing purposes, but in dry cleaning and washermen and washerwomen, they must be using this powder as a washing powder. Anyway, so washing soda, that is the common name. This is very, very important. The common name and chemical formula, chemical name and chemical formula definitely comes in section 1. So, chemical name and then chemical formula. Okay. So now washing soda is the common name. Okay. So washing soda. The chemical name is sodium carbonate. And the chemical formula is Na2CO3.10H2O. So that means each molecule of this sodium carbonate has 10 molecules of water associated with it. So the formula is Na2CO3, Na2CO3.10H2O. Okay. So this is the common name washing soda, chemical name sodium carbonate, chemical formula Na2CO3.10H2O. Okay. Then next one is Epsom salt. Okay. So that is the common name Epsom salt. The chemical name is magnesium sulfate. And the formula is MgSO4.7H2O. Okay. Then potash alum. That is the common name. Chemical name is hydrated potassium aluminum sulfate. Hydrated potassium aluminum. This I was discussing in double salt. Do you remember? Aluminum sulfate. And the formula is K2SO4 dot Al2SO4 thrice dot 24H2O. Okay. Then you have Glauber's salt, that is the common name. The chemical name for Glauber's salt is sodium sulfate. And the formula is Na2SO4.10H2O. Na2SO4.10H2O. Okay. Then you have blue vitriol. This is very commonly asked. Blue vitriol, that is a common name. Copper sulfate. These are all hydrated salts. CuSO4.5H2O. Okay. This blue vitriol, when you heat it, it becomes white and it loses the 5 molecules of water. Then plaster of Paris. Plaster of Paris is nothing but hydrated calcium sulfate. Calcium sulfate, and the chemical formula is CaSO4 dot half H2O. Okay, then you have white vitriol. This is the common name, and chemical name is zinc sulfate. And the chemical formula is ZnSO4 dot 7H2O. This number of water molecules is what you have to be very careful to remember. Okay, you have little write and practice, then you will remember them. Then the last one, gypsum. This is again very often asked. Gypsum. Okay, and the gypsum is the common name, and the chemical name is calcium sulfate. To be very specific, hydrated calcium sulfate, and it has CaSO4 dot 2H2O. Okay, so these are some of the hydrated salts, their common names, chemical names, and chemical formula. And definitely any two are usually asked out of this list, so there is no other option but to by heart this. Okay, then you have to learn another term called efflorescence. Now, efflorescence, as a definition, it is very important. Now, what is this efflorescence? Efflorescence is a property of some salts to lose wholly or partially, that is completely or incompletely, their water of crystallization when their crystals are exposed to dry air even for a short time. They become powdery. Such substances are called efflorescent substances. That is, when these hydrated salts which contain water molecules in their crystals, when they are either exposed even to the atmosphere, some of the water molecules either evaporate or escape out. All the water molecules may not, partially some. If there are 7 water molecules, sometimes 2 water molecules escape and 5 remain, or sometimes all the water molecules evaporate. So that process is called efflorescence. Is that clear? So let me write the definition. Efflorescence is the property of some salts. Some salts means which type of salts? Hydrated salts. What is the property? To lose wholly or partly their water of crystallization. That is called the efflorescence. Okay, when they lose their water of crystallization, when they are exposed to dry air. Now, such substances are called efflorescent substances. Okay, and the process is called efflorescence. Okay, now example, washing soda. Washing soda. What is the formula? Na2CO3 dot 10H2O. When it is exposed to dry air, it loses those 10 molecules of water. It loses partially. Here it does not lose all the 10 molecules, it loses 9 molecules and retains 1 molecule of water. That is Na2CO3 dot H2O plus 9H2. Okay. Similarly, when Glauber salt, that is Na2SO4 dot 10H2O is exposed to dry air, it forms Na2SO4 and all the 10, it loses all the 10 molecules of water. Okay. Now, is that very clear? So, what are efflorescent salts? Efflorescent salts are those salts which lose their water molecules when they are exposed to dry air. And what is efflorescence? Efflorescence is the process or the phenomenon or the property of salts to lose partly or wholly the number of the water molecules associated with their crystals or water of crystallization, that is called, when they are exposed to dry air. Okay, is that clear? Then one more definition. Hygroscopic substances. Hygroscopic substances. Now, some salts absorb moisture or water vapor from the atmosphere without dissolving in it. So, they absorb the water vapor from the atmosphere, but they do not get dissolved in that. Such substances are called hygroscopic substances and the phenomenon is called hygroscopy. So, example, Kong sulfuric acid. You have already learned this while laboratory preparation of hydrogen chloride or hydrochloric acid. To dry the gas, we use Kong sulfuric acid as a drying agent. Why? Because of this hygroscopic property. What is this property? They absorb the moisture in the air or whichever gas they are, that is in their contact, they absorb any moisture that is present in them. At that time only you learnt that quicklime, CaO, and phosphorus pentoxide in hydrogen chloride lesson only you have learnt that these two drying agents are not used to dry the hydrogen chloride gas. Why? Because hydrogen chloride gas reacts with them. But these two are also hygroscopic substances. They also have the property of absorbing the moisture. Okay. So, these substances which have the property of absorbing moisture are called hygroscopic substances. Okay. Is that clear? Then one more definition. Okay, before we proceed further, these hygroscopic substances are also known as dehydrating agents. Dehydrating agents. This term also you have come across in your hydrogen chloride chapter. Okay, so dehydrating agent or hygroscopic substances mean the same. They have the property of absorbing moisture. Okay, then the last term that you will be learning in this chapter is deliquescent substances. Deliquescent substances. Some salts absorb moisture from the atmosphere and they dissolve in it. Okay, like for example, hygroscopic substances they absorb but they don't get dissolved in that. But deliquescent substances, some substances, when they are exposed to atmosphere at ordinary temperature, absorb moisture from the atmospheric air and they become moist or sometimes ultimately even dissolve in the absorbed water. So this you must have observed in with your common sodium chloride, common salt. This also you must have seen that if it is not kept in airtight container, it becomes moist. Okay, so anyway, so such substances which absorb moisture from the atmosphere and become slightly if not completely dissolved, but they become wet. Okay, such substances are called deliquescent substances. So the examples of deliquescent substances are caustic soda, then you have caustic potash, magnesium chloride, zinc chloride. So all these deliquescent substances you have to store in airtight containers. Even table salt, that is sodium chloride, turns moist and sometimes it even becomes watery, liquidy. It dissolves in the exposed air. Okay, that is why you must have seen those salt dispensers with small holes. After some time, the salt doesn't come out of those holes. Why? Because the salt absorbs water, moisture from the air and becomes moist and wet. Okay, so that completes this chapter, acid base salt. Okay, so now my dear children, let me stop here. Thank you for watching and go through it. This is a very simple but important chapter. Okay, take care. God bless you.